Alrighty, my party people, and welcome into day 2 of our volume and surface area class. So today's class, we're still gonna, even if you weren't here in yesterday's class, if you're here live, we're still gonna refresh on those formulas and some of the work that we did in terms of plugging and chugging. But the main focus of today's class is really going to be, how do you spot surface area and volume? How do you spot them in word problems? And then how do we stay calm? How do we avoid freaking out when it comes to just trying to solve the problem as a whole? So even with yesterday, who here feels like even though we went over the formula, we still are not quite confident with word problems? Who feels that way? Yeah, that's a lot of us, right? Word problems. Yeah, ugh. Yeah, I understand where you're coming from. And it makes total sense because in the previous class, in yesterday's class, all we did was go over the formula, plugging and chugging and solving the equation. And that's it. So today we're going to be looking at a whole new side of things where we're going to be understanding, hey, how do we know we're looking at surface area? How do we know we're looking at volume? And then how do we know what we're supposed to solve for? That's what today is about. So even if you weren't here in yesterday's class, we're still going to go over the formula. And when it gets to the word problems, if you feel like you're a little stuck in terms of solving and plugging and chugging, don't worry at all, because again, that was in yesterday's class. That's recorded. You can watch it. But today's focus is, again, those key words and breaking the word problems down. So I'm going to quickly go through these slides here. So if you weren't here yesterday, pretty much what we did was, number one, we went over the formula for volume over here and surface area over here. And we just went over those formulas, length times width times height for the volume, and surface area was this big old blob right there. Now, really quick, for those of us that were here yesterday, who here feels like this made sense? The 2L plus 2W, the 2LW plus 2WH plus 2LH. Who here feels like that actually made sense to you in terms of surface area having two sides that are the same, the left and the right, two sides that are the same, the bottom and top, two sides that are the same, the front and the back? That's good. Awesome. Now we're going to be applying this into word problems. So after we went over the formula, and actually before I move forward, I'll give it 10, 15 seconds here. In case you weren't here, please go ahead and take a screenshot of this. But more importantly, if you don't have access to a screenshot device, this is really what you want to write. These two things right there. Both of your formulas. And if you have enough time, writing this as well. So after we went over the formulas, everybody, we went ahead and practiced with the formulas. All we did was really get comfortable with, hey, if we're given pieces, can we plug them in and can we solve for the volume? We did this directly or working forward. We also did this working backwards in terms of, hey, what if I already give you the volume and two of these three pieces? What are you going to be doing then? And that's what that was about in terms of this entire page. And so we did the same thing as volume as with surface area. The direct way, moving forward, where all we had to do was just plug in those values. And then we worked backwards over here, where I gave you the surface area and two of the three dimensions, and we had to work backwards. Right on. And I'll take a little. That's perfectly fine. Sweet. So let's go ahead and move forward to what we're going to be doing today. Today, we're going to be practicing really spotting these key words and understanding, hey, what do these keywords mean? Because this is where getting those points on the test, this is where it happens, where you can look at context, look at a word problem, and not get so focused on the numbers, but instead focus on what the numbers mean. So let's go ahead and try this out, everybody. So first things first, what are we trying to find here? What are they telling us that we are looking for, that we are solving for? What is being stated here? And that's right. For those of us that are saying find the length, yes, that is absolutely correct. because we always look at that last sentence where they give us the instruction. So right here it says find the length. Now, everybody, just based off of that right there, just finding the length, does that tell us if we're working with surface area or volume or even perimeter or anything? Does that by itself tell us everything we need to know? Correct. No, that doesn't tell us everything we need to know. Just this part right here, that doesn't tell us everything, but it tells us what we're looking for. And if you've been to one of my classes before or you've seen any of my videos, you know that the main thing that I always say is start with the question, start with what you want, because it's so easy to fall into that trap of test anxiety when you're not prepared to take in and filter the information. So the first thing we'll do is we'll just say, hey, we want to find the length. I'll just write that right over there. Now, the next thing I'll do is try to understand and make sense of the information. So this is a big test taking tip that I'm going to be giving you here. And I already said it before, and I'm going to say it again. It's not about the numbers. It's about what the numbers mean. So let's take a look here. It says a shipping box must hold 600. So don't focus on the 600, but focus on the cubic inches. That's what we want to focus on. My party people, it says the shipping box must hold 600 cubic inches of material. What does cubic inches mean? And I already see some of y'all in the chat box, blasting it away. Yeah, the key there is cubic. Cubic inches. That is a 3-dimensional unit. That's also the same thing as saying 600 inches cubed. When we are talking about a 3-dimensional unit, that is volume all day. So for those of us that may not have been here in yesterday's class, if you're watching this as a recording, you need to go back and watch that first video because it was great. But now if you're here live, let me go back into the slides here, back into the formula. So this is something that was very important that we went over, because when we talk about area, area is 2-dimensional. Surface area is also 2-dimensional, because all we're doing is looking at the flat space, all the space at the top, on the right, on the front, on the bottom, on the left, and in the back, and we just add up all of that flat 2-dimensional space. And that's why area, again, 2-dimensional flat surface, it's always square units. So it looks like this, a unit squared to the power of 2. So it could be feet squared, inches squared, centimeters squared, miles squared, could be whatever squared. But that's going to indicate area. Volume, the reason that it's 3-dimensional, like we talked about yesterday, is because we are multiplying 3 dimensions together. The length, the width, and the height all together multiplied gives us a 3-dimensional unit. And that's how we can tell in word problems if we're given a 3-dimensional or cubic unit. That's how we know. So one more time, volume is cubic, area is square units. And just to look at the formula again, if you take a look, let me zoom on in, you'll notice that we're only multiplying 2 dimensions at any given time. We are never multiplying 3 dimensions together, it's just 2. So although, yes, 3 dimensions are present, they are not all being multiplied together at the same time. My party people, before I continue, does this make a little bit of sense to a lot of sense in terms of, again, identifying the difference cubic versus square in terms of those units versus volume and area? Sweet. That means that this is going to be a lot of fun. So with that, let's go ahead and bring it right back to that problem that we were getting after. So we see here that they give us 600 cubic inches of material. So we now know that that is volume. And then it says its height is 5 inches and its width is 6 inches. So we have those two pieces. So again, the height that's given to us, that's going to be 5 inches right there. And then the width that's given to us, that is 6 inches. So with that said, everybody, do we have enough to solve this problem? Oh yes, we absolutely do. Because we have the volume given to us, and we know the volume deals with the length, width, and height, and we have the height, we have the width, so we're only missing one piece. We can solve that if we're only missing one piece. We can absolutely solve that. But pop quiz time, everybody, what is the formula for the volume of a rectangular box? What is the formula for volume? Queen, appreciate you. Angel, thank you. Yes, it's going to be volume equals length times width times the height. Absolutely. So now what we can do is do exactly what we did in that previous lesson in yesterday's class, where we said, hey, we have the volume given to us. So I'm going to highlight that right there. I'm going to replace the volume with what it is. I'm going to replace the height with what it is. And I'm going to replace the width with what it is. So that way I can solve for the length. So everybody help me out. What am I replacing the volume with? Hit me. Oh, Queen, you wrote the whole formula out. Perfect. Yes. So we're going to have 600. We're going to have 600 equals. The length is just going to be the length because we don't have it yet. And then the width and the height, we'll replace it with the 5 or in the 6. It's the 6 first for the width, but really, since we're multiplying, the order really doesn't matter. But there we are. So before I continue, my party people, are we feeling good about this particular problem in terms of, oh yeah, we definitely know that that's volume because of cubic inches, and that tells us to use the volume formula, and then we just plugged in what we have, and we're good. And that's it. Let's go. I'm glad. I'm very happy with y'all. So with that, let's go ahead and get into it here. Let me zoom on in and let's solve. My party people, you know I'm bad at math. What is 6 times 5? Yeah, that's going to be 30. Appreciate y'all. And so we can say L times 30, or we can just rearrange it and we can just say 30L. It's the same thing. There we are. And I'll just erase that right there. And we're good. 30L works just the same. So just as a refresher, solving equations, we're looking to work backwards. So my party people, working backwards here means we will do what to both sides? Yeah, we'll divide, but divide by what? Yeah, we'll divide by 30, correct. So let's go ahead and do that here. Divide 30 and divide by 30. So once we have that, on the left side, it'll just cancel out because 30 divided by itself will just cancel out to a 1. And then we have 600 divided by 30. One thing we can do is we can cancel out that 0 at the end of each because that's the same thing as dividing by 10. So essentially, what we're really doing is 60 divided by 3. Everybody, what's 60 divided by 3 going to be? Yeah, that's going to be 20. L equals 20. And there we are. Our length is going to be 20 inches. So that is the length of the box. And there we are. We're all good. There's our answer. And notice how we were able to do a problem that involved volume working backwards as the very first problem. So on a scale of 1 to 10, with 1 being I still have no clue what I'm doing, with 10 being this problem made total sense, where are we currently at? It's pretty promising so far. A lot of answers here over 6 and above, so that's pretty good. Even if we're below a 6, remember, what we're here to do is really focus today on keywords. So that's a great question by, who was that? By Shaletta. So Shaletta, great question. How do we know the difference between volume and surface area? So right here, remember that volume is 3-dimensional. And so having cubic inches, That is the dead giveaway. That was the dead giveaway that we are dealing with volume. Now, if we take a look at the next problem, we might see something different. Everybody, if we focus on the question on this next problem here, can you tell me what the difference is between this question and the previous? Yeah. Notice how this question says, how many square feet of surface must be painted? So there are two huge giveaways. Number one, square feet. That tells you that you're dealing with area of some kind. It could be regular area or it could be surface area. We're wondering if we're dealing with a flat shape or a three-dimensional shape, because you can take the surface area of a three-dimensional shape. If it's a two-dimensional shape, it's just area. So when we take a look here, it says we need to paint every face of a rectangular crate. So what we're essentially looking at, and you guys know me, I am very good at freehand drawing. So I'm going to draw freely with my hand. That blue is gonna go away right there. And then we are going to copy that. Again, I'm a great freehand drawer. This is all me freehanding it. This is not technology. There we go. There we go. All right, boom. Now let me do some erasing here. And that way, right on. All righty. And then do a little more erasing here just to really drive the point home. Boom. So there we are, my party people. Look at that, all freehand drawn. I'm going to print that out, put it on my fridge later. But the point remains. Notice how we're talking about a rectangular crate. This would be that rectangular crate. And we're trying to paint every face. So we're not trying to fill the crate up. No, 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 no. What we're trying to do is we're trying to paint every face. So we're trying to paint the top, the bottom, the left, the right, the front, and the back. My party people, is this making a little more sense in terms of the difference between volume and surface area? You tell me. Yeah, because notice how we didn't say how many cubic feet of paint can the crate hold. That's not what we're asking. We're talking about the surface being painted. How much space, how many square feet of surface must be painted? And that again is going to be surface area. Square feet is area, and we're talking about the surface of this three-dimensional shape. So that right there, my friends, surface area. So with that, pop quiz again in the chat box. Let me know, what is the formula for surface area? Hit me. Alen, thank you. Or if that's an I, that's Ian, excuse me. Virginia, correct. Townsend, correct. Yep, and let's go ahead and write this here on the screen. That way we're all good together. Let me move you up here, and then let's go ahead and write that surface area formula. Surface area equals twice the length times the width, because there's two faces that are the same, both using length and width. There are also two faces using the length and the height, and then two faces using the width and the height. So now that we're here and we know for a fact that we're looking for surface area, my party people, does that make it easier for you personally to just plug and chug at this point? Does that make it easier for you personally? Yeah, it does, right? So let's go ahead and give it a go. Let's go ahead and plug in these values and just see what happens. So we have 8 feet by 4 feet by 3 feet. They didn't exactly tell us which is the length, which is the width, which is the height. And it, really doesn't matter. We have all three dimensions, so we can just go in order if we want to, but it really doesn't matter in this case. We have a length of 8 feet, width of 4 feet, and then the height of 3 feet. And again, order doesn't matter in this case. Any which of these could have been the length, the width, and the height respectively. So now that we've made a choice, let's just go ahead and plug and chug. Let me use a highlighter here to make things much easier than they are. So let me use purple for the length, green for the width, and red for the height. Here we go. Surface area equals twice the length, which is 8, times the width, which is 4. Then we'll continue adding on twice the length, again, which is 8, the height, which is 3, and then we're adding twice the width, which is going to be that 4, and then the height, which is the 3. And there we go. Before I continue, can y'all double check for me? Can y'all double check that I plugged everything in correctly before I move forward with a mistake? Right on. And Shamira, to answer your question there, I would really give it a go the straightforward way, right here, plugging in the numbers, really getting used to that motion. So, just to make sure I say this for the recording. So Shamira is asking, so can we just multiply each number by 2 and add them all together instead of writing out the formula? Because the formula kind of confuses me. And that makes sense. I understand where you're coming from. But the more important thing is, why is it confusing? It's probably confusing. If I had to guess, it's probably confusing because we just don't have that experience with it. We don't feel like we've done it enough times to feel comfortable with it. If that feels like that makes sense to you, then that's why we're here in this class. That's why, right on, yeah, I gotcha. So, that's why we're in this class, to be in an environment where we can practice without, getting points off on the actual test. That's why we're here. We want to develop that comfort and confidence, and it's important that we do it the right way from the very beginning. I know it's definitely tempting to take shortcuts, but taking shortcuts when you don't know the actual route leads you to perhaps the wrong destination. So let's go ahead and get into it here. We plugged in each of our values exactly where they belong, so we know that we're good. So now I'll go ahead and zoom in here, and let's solve. Here we go. So surface area equals 2 times 8 times 4. Now that might seem like this is a little daunting, but just like I did yesterday, remember that you want to put yourself in a position to succeed. For example, you might want to do, 2 times 8, that's 16, but then 16 times 4? That's a little complicated, right? You may not know that off the top of your head. And hey, fair enough. But think about it like this. What if we just did the 2 times the 4 first? That's going to be 8. Everybody, what's 2 times 4? That's 8, but what's 8 times 8? What is 8 times 8? Yeah, that's just going to be 64. So notice how we can avoid doing, 2 times 8 times 4. We can avoid doing 16 times 4 and then having to write it out and taking all that time. Instead, we can just go ahead and do this. We can say, hey, let's grab these two first. That makes 8. Multiply the 8, and that's 64. So the order in which you multiply doesn't matter. 1 times 2 times 3 is the same as 3 times 2 times 1. Give yourself that opportunity to work a little faster when you can. We can do the same thing over here as well. We can do the same thing right there because, hey, 2 times 8, that's 16, but what's 16 times 3? You may not know that off the top of your head. I encourage you to practice that. But in case you didn't, we can just do 2 times 3, which is 6. Everybody, what's 6 times 8? Yep. And that would be 48. So do we understand where I'm coming from when I am encouraging you to just analyze what the numbers are to give yourself an easier time? Sweet, right on. And I know half of us are still writing things down, and I got you. So let's move into this last part right over here. So this one's going to be a little easier because 2 times 4 is 8. 8 times 3 will be 24. So we essentially have all that we need here. And now all we have to do is add these 3 values together, and we're set. So there's a couple different ways. Mental math is always my best friend, but we can go ahead and write things out just the same. We can do 64 plus 48 and 24. And then what we'll have is 4 plus 8 is 12. 12 plus 4 is 16. Carry the 1. Then we have 6 plus 4 is 10. 10 plus 2 is 12. 12 plus 1 is 13. So we have 136 for the surface area. Pop quiz, my party people. It'll be 136. What are the units? What are the units for this particular problem, for the surface area? Mira, correct. Oh, well, no, not quite. Not square inches. It is a square unit. I'll give you that for sure. It is a square unit, but it's going to be square what? Yeah, square feet. Right here. Square feet. And we know that each of the dimensions was given to us as feet. So we're good. We have 136 feet squared, or you can just say square feet. Either way is correct, but there it is, my party people. There's our final answer, 136 square feet. Who here feels like their confidence is slowly rising as we go through these examples? Hey, there we go. Remember, everybody, at first, if it's rough and it feels a little tough and confusing, I really want to just shout out everybody here who's continuing to show up even through the confusion, because when you have that breakthrough moment, when you have that quote light bulb moment, and we know that we can have those moments, and when we do have them, it really opens the door to these skill sets that are going to help you get the score you want on this test. So great job so far, everybody. We're about a quarter of the way through class, a little over that, but we're doing a great job so far. So I'm going to show the next question shortly, but I want to give you an opportunity to take a screenshot here if you need to. And I want to ask y'all, would y'all like to try the next one on your own? And the only thing that I'm going to ask you to do is to point out whether we're working with surface area or volume. That's all I'm going to want you to do. And then the rest we'll do together. But I'm going to give you 1 minute. And after that 1 minute, again, we'll work it all out. But if you want to try to work out as much as you can, sure, go for it. But the only thing I care about in this 1 minute is, can you determine whether this is a problem involving volume or surface area? Bonus if you can go ahead and fill everything in. So let me get the timer up on the screen. Let me reset the timer over here. All right, there we go. Let me just bring it down to just a minute flat. I'll give you an extra 5 seconds as a buffer. All right, so go ahead and try this next one out, everybody. There it is. 1 minute. Don't reveal your answers. Don't reveal the answers at the countdown end. Then let me know what we're dealing with. But for right now, keep it to yourself. And that's time, my party people. So let me know in the chat box, what are we dealing with? Is it surface area or volume? Which of those ideas are we working with here? Okay, looks like the vast majority of us are agreeing that it is volume. Right on. Now, I gotta ask you to defend your answer because I'm not just sitting here, gonna act like we're parrots and you're saying volume, 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 and I'm gonna just repeat that myself. Can you give me some confidence here? How do I know that this is volume? How do I know? Yeah, so I see two different answers, but the majority of them are saying cubic inches is what gave it away. And that is the correct answer. It is cubic inches. That is one of the dead giveaways that we're dealing with volume right there. How many cubic inches? No worries, Keon. No worries at all. Now, the shape, yes, it is a three-dimensional shape. But remember, everybody, just because it's a three-dimensional shape doesn't mean that it's only ever going to be about volume. We could be given a three-dimensional shape and we could be asked to do surface area. We could absolutely be asked that. So before I continue, does that make sense? It's not just that it's a three-dimensional shape. The three-dimensional shape means, yeah, it could be volume or surface area, but the true hint or the true giveaway right there. How many cubic inches of water does it hold? Yeah, that's the key. Also, another clue, I'm going to highlight this in purple, not red. It's right here. It is filled with water. So filling something up, yeah, we're talking about the space that it's holding, the three-dimensional space in this case. Yeah, the space inside of it. That, filling something up from bottom to top, that is indicative as well of volume. But cubic inches, that is the safe dead giveaway. So we know that we're dealing with volume. So pop quiz again, everybody, quickly in the chat box. What is the formula for volume? Give it to me. I'll write it down on the screen, and then we'll get to solving. Appreciate you, Jasmine. Binta, Ian, Townsend, appreciate y'all. Make sure to use the equal sign next time, but we're good. So yeah, volume equals the length times the width times the height. Again, specifically for a rectangular prism, a rectangular box. So here, let's go ahead and plug everything in now. We're looking for volume. The length that we're given is 8 inches. The width is 7 inches. And the height is 3. So that's all I'll plug in. 8 times 7 times 3. And so 8 times 7, that's going to give me 56. And then I'm going to multiply 56 by 3. So 56 by 3, one step at a time. 6 times 3 is 18, and we'll carry that 1. 5 times 3, that's going to be 15. We'll carry the 1, and that'll be 16. And there we are. Our answer here for the volume is 168 cubic inches. And there we go. So remember, it's not about the calculation. It's about, can we point out what we're actually trying to do? Who here felt like this one was easier than it would have been a couple of days ago? Excellent. Sounds good. Sweet. And yeah, so just to make it very clear here, let me go back to addressing this person properly. Yannick. Hey, Yannick, welcome in. So, Yannick's question was, is there a different formula for a cube? Yes and no, because a cube is a rectangular prism. The sides are all just the same. So the length, the width, and the height, they're all the same, so you're good. And there is a, quote, shortcut formula that makes it even easier. Kind of like how when it comes to the area of a square is just the side times side, and the perimeter is just 4 times the side since the sides are all the same. With a cube, you have 6 faces on that cube that are all the same. So the surface area of a cube is just, hey, take the area of one of the faces and just multiply it by 6 because it's 6 identical faces. So there's a nuance to it. And yeah, you're welcome, absolutely. But yeah, it's going to be the same essential formula, but there is a way to write it in a shorter manner. So with that, let's go ahead and get into this last problem here. I want to give you all the same opportunity. I want to give you all another minute to try it out on your own, where your only goal is to tell me whether this is volume or surface area, and then you can take the remaining time to try to complete as much as you can. But the main goal, again, is just pointing out if this is volume or surface area. You guys ready? All right, let's give it a shot here. Timer starting. 3, 2, let's go. Give it a shot. And that is time, everybody. Go ahead. Let me know in the chat box, are we dealing with surface area or volume? Yeah, and I think this one was pretty easy, right? Pretty easy to spot because we are quite literally told, hey, yeah, we are looking at the total surface area of this box right there, 148 square inches. So one more time, everybody, I know I just said it, but even though they give us directly that we're dealing with surface area, how do we know? What is the giveaway that we're dealing with surface area? What is the giveaway? Excellent. Yes. Square inches is part of the giveaway. It's part of the giveaway. But what alongside square inches gives it away? And it's not going to be surface area. Again, ignoring that. Ignore this. What is the other? Yes, right there, Tiara. That is absolutely correct. Find the height. We have the length. We have the width. Find the height. That is the difference between regular area, so just 2 dimensions, a length and a width, versus 3-dimensional, where we have the length, we have the width, and we have a height. 3-dimensional, so that's surface area, not regular area. Who here understands what I'm saying when I say that? That we have a length, a width, and a height, and that's what makes it 3-dimensional. And that's why we know we're talking about, again, surface area. Right on, Jasmine. Anybody else? Sweet. Right on, Jeremiah. And Virginia, perfect. So let's get it going. Oh, JMO, I got you. So basically all I said was, we know that this is surface area and not regular area. It's because of this. Regular area is 2-dimensional. Regular area, if we're talking about like a box like this, we're talking about a length and a width, or a base and a height, however you want to say it. But regular area, 2-dimensional area, we would just be talking about a length and a width. Notice here, we're talking about a length, a width, and then finding the height. So that means what we're doing here is we're talking about a box. We're talking about a 3-dimensional shape, and we're given its surface area as 148 square inches. So that's what we're referring to there. So with that said, pop quiz. Now that we know we're dealing with surface area, give me surface area's formula in the chat box, and I'll begin to solve with you step by step. Go ahead. So let's write it out here together. I got y'all. I got you. No worries. So here we are. It is surface area equals twice the length times the width plus twice the length times the height plus twice the width times the height. So remember, if you're having trouble memorizing the formula, all we have to remember is that the length, width, and height, they all get in, they all interact with each other just one time. So the length and the width, length and the height, and the width and the height, they all mix and match one time. And that's how you know that you're good. If you have length times width, length times height, but then length times width again, that's how you know that, hey, I messed up. So let's go ahead and get into it here. Let's plug in the values that we have. Everybody, what is the surface area? What was given to us for that value? That's right, 148. So I'll plug that right in as 148. Next up, so we have twice the length, and I'm just going to write out the length and the width that was given to us, because we have the length right here is 5 inches, and then the width right over here is given to us as 4 inches. So we'll use that and plug everything in knowing that. So our length right over here is 5, and then our width is 4. Then we just continue plugging and just make sure you're careful about this. We're engineering right now, just plugging things into the right places. So our length is going to be 5, so we'll plug that in again. And we don't know what the height is, so I'll leave that as is. Just leave that as the height. Again, we're looking for the height. Next up, we'll go ahead and do 2 times the width. The width is 4, be very careful here. And then again, the height, that is what we're looking for, so we'll keep that the same. And so there we are. Now that we've plugged everything in correctly, notice that all that's left to figure out is h. So let's clean this up and let's see what we can do after we clean it up. Everybody, here we go. We are going to look first at the 2 times 5 times 4. 2 times 5 is 10. 10 times 4 is, my party people. Yep, that's going to be 40. So we have 40. And then we're going to be adding that with 2 times 5 times h. 2 times 5 is 10. 10 times h, we'll just write that as 10h. Moving forward from there, we'll continue on by saying 2 times 4 is 8, and that will be 8h. And so again, just to make sure I'm reassuring you, all we've done at this point, all we've done was plug in the right values into the right places, and then we're going to let the rest take care of itself by solving this equation. So let's do combining like terms right here with 10h and 8h. My party people, what is 10h plus 8h? Yeah, that'll be 18h. So now we have 148 equals 40 plus 18h. Excellent. Now, this is where things might get a little confusing for some folks who might not have that experience with solving equations. And that's fairly fine. That's okay. But you need to be able to acknowledge that this is where you're stuck. So let me go ahead and just duplicate this over here so I can finish solving this. Let me make this a little smaller, and I'll push that over there. So let's focus on solving this. How do we get this done? Remember that it's all about working backwards. So we're trying to get the h by itself. There's a 40 sitting there and there's an 18 sitting there. What operations are we currently looking at? We see that we are multiplying 18 times h, and that 40 that's just sitting there, it's being added. It's just, if a number is just sitting there, we know that that number is being added. So that's the first thing we'll take care of. And if this is a little weird for you, another way that you can look at this is like this. Because remember, 1 plus 2 is the same as 2 plus 1. 1 plus 2 is the same as 2 plus 1. So I can write it like that if that makes me more comfortable. So the first step that I must take is to subtract the 40 on both sides. Once we do that, Then I can move forward by dividing the 18. So I see here, that's going to cancel out. Everybody, 148 minus 40 gives me what? Right on, that'll give me 108. 108 equals 18H. All right, now from here, we are going to be dividing, just like y'all said in the chat box. Great job there. We're going to be dividing both sides by 18. So let's take purple here, divide by 18 there, and 18 right there. Perfect. And then let's cancel that out. And so, whoa, what is 108 divided by 18? That seems a little rough. But just like we talked about yesterday, I love it, Elise. I love the excitement. So just like we talked about yesterday, if it's not obvious what it is that these big divisions are, go ahead and simplify first. Everybody, because 108 and 18 are both even numbers, what can we divide from both of these numbers? What can we simplify by? Tiara, correct. That's going to be 2. Even numbers are divisible by 2. So let me move this over here, and I'm going to divide the top and the bottom by 2. I'm going to see where that leads me. If I start by simplifying right there. If I do that, 108 divided by 2, that's 54. 18 divided by 2, that's 9. Everybody, did this just become a lot easier? Yeah, absolutely did. And that's why learning how to simplify is a very good skill that we should all be focused on. But there we are, 54 divided by 9, that's going to be 6. And there we are, 6 inches is our height. And there we go. I know that felt like a lot, but when you look at this in the grand scheme, notice how simple it actually was. We have a problem regarding surface area. We noticed that it was surface area, so we wrote the formula out. From there, we plugged in what we know. We plugged in surface area, we plugged in the length, we plugged in the width. And then all of this rest of the stuff here that looks kind of complicated, all we did here was just solve an equation. So with that said, who here feels like they understand what their main issue is? Whether it's memorizing the formula, whether it's plugging things into the right places, whether it's solving an equation confidently, do you personally understand what your core issue might be? Right on. And if so, let me know what it is for you. I want to take a chance here, or take a moment here, to really hear you out. I want to know what you personally feel is your biggest challenge at this moment in time. Whether it's the formula, whether it's plugging in, whether it's solving equations, what is your toughest go at the moment? Am I simplifying division? I gotcha, okay. Key on plugging in, solving equations, remembering what formula to use. How do I know if I subtract 40 or 18? Jasmine, that is solving equations right there. Yeah, that's entirely involved in knowing how to confidently solve equations. Formulas, Virginia. Solving equations and plugging and chugging, I gotcha. Devon, I got you. I got you. Yeah, we're not done. We still have a full hour. We're good. And I'm glad you're excited. I'm glad that you want more. I'm glad that you want to solidify this concept. We got plenty of time. We're good. All right, solving equations, simplifying. So there we go. So take that into consideration, everybody. Take that into consideration for yourself, because those of you who are here in class, very likely you're in the program. And so with that said, you know what you need to do now. You know what your core issue is, and you know how to get the practice that you need. So don't sell yourself short. Look forward to doing what you need to do to build that confidence, because you know that I'm right here with you every step of the way. So great job so far, everybody. Now what we're going to do next is we're going to have some timed practice. Now remember, there are steps to this. There are 2 phases to really any word problem. Phase one is, hey, can we make sense of the problem and turn it into math? Can we translate the English into math? And then step two, or phase two, of every word problem solution is actually doing the math. So some of us might feel like we're better at translating the English into math. Some of us might feel like we're better at actually doing the math. This is only going to help us reveal what those issues are, and then the nuance, those little finer details of how we can build confidence the right way. Are y'all ready to try out your first time practice problem? Perfect. Let me just set this up here for 3 minutes. Sweet. And remember, all I want from you, all I need is your best. If your best falls a little short, that's okay. That's okay. Because we can't hit a home run the first try. But if we continue trying and we continue asking why, then we can absolutely get there. So for those of us that are still confused or feeling like we're not as confident as we should be, remember that you want to do what you can. First step is read the question sentence, not the whole problem, the question sentence. Can you point out what we're looking for? Then, can you write down the information and tell a story? Can you point out what those pieces of information mean? Then, can you set up the formula? Choose the right formula and then set it up. And then from there, can you solve it? And that's it. If you run out of time, don't worry. I know 3 minutes might feel like a short amount of time, especially if you're still refreshing, and that's okay. But just do what you can, and I'm here to take it further. So here we go. 3, 2, 1, let's go. All right. And that is time, my party people. Go ahead, put those answers in. Let me know what you have. Put a question mark next to your answer if you feel like you might be taking a guess. And again, there's no shame at all. If you feel like you ran out of time, that's fine. That's totally fine. We are here to explore and build confidence on what we know how to do, and then really dive deeper and explore what we quite fell short on, and that's okay. So let's go ahead and get into it here, everybody. First step is read the question sentence. My party people, what are we instructed to find? Correct. We're instructed to find the height. That's what we're trying to do. So let's go ahead and highlight that right over here. Find its height. So you don't need to be a pro at surface area and volume. You don't need to be able to read. Find its height. That's right there. So boom, I'm going to write right over here. I am looking for the height. Sounds good. Now, we're going to explore the information that's given to us to see how we can turn all of this English over here. How can we turn this into math? So let's go ahead and let's get ready to read here. A rectangular hamper is this wide, this long, and it can hold 54 cubic feet of clothes. Everybody, which concept are we dealing with? Surface area or volume? Yeah, it's going to be volume, and the reason is because cubic feet. We are shown a three-dimensional unit. Cubic feet is the giveaway. That is the giveaway. So what we know about this rectangular hamper is that its volume is 54 cubic feet. And so, pop quiz, what is the formula for the volume of a rectangular box? What's that formula going to be? Queen, thank you. You already knew what I was going to ask. So volume equals length times width times height. So right there, length times width times the height. So with that said, let's plug in the values that we have and then move forward from there. So we have our volume, which is 54. We are given the length right over here, 2 feet long. So I know that. So I'll plug that in for 2 for the length. And then we see that the width is 3 feet wide. So great, I'll plug that in as well. And then we're looking for that height. So I'll leave that as is. So from here, to solve this, we just need to clean things up and then solve the equation. Notice that we are given the volume already. So it's not like we're just going to multiply these 3 things to get the volume. No, we have the volume and we got to work backwards to find the height. So we have 2 times 3. That's going to give us 6. So that'll be written as 6h. And then from here, this is where we take a nice look and we say, well, we're multiplying by 6 to get 54. So to work backwards and get h by itself, we will divide by 6 on both sides. And once we do that, cancels out on the right side. And so then we get 54 divided by 6, and that will be 9. And there we go. Our height is 9 feet, making the correct answer C, 9. And there we go. There we go. Now, I saw a question here in the chat box that I'm going to answer. I got you, iPhone. So how do you determine that the volume is 54? That was a bit confusing for me. No worries. So the giveaway, like we've been talking about here in today's class, the giveaway is not the number, but the units. Cubic feet. So remember, cubic feet talks about a 3-dimensional unit. Cubic, that's the 3rd power. That's 3-dimensional right there. Volume is a 3-dimensional unit. And that's how we know that this is volume. If they would have said, hey, this rectangular hamper, it needs 54 square feet of paint, then that would tell me that we're talking about area because we said square feet. In this case, it's cubic feet, so that would be volume. So there we are, my party people. And I'm glad that some of y'all are excited about getting this question right. So on a scale of 1 to 10, where was your confidence with this one as we went through it? And no worries, iPhone, I got you. Right on. Looks like a lot of us are feeling like this was a 10 out of 10. A couple of us feeling like an 8, 7, a couple 5s there, but most 10s, 9s. Okay, sounds good. So remember, Eve, if it was not a 10, we have got to be honest and ask why. What did I feel like I did well, but where did I get stuck? And let's see if what I helped you or what I did, let's see if that helped you out even a little bit, because we're going to move forward to the next question and try again. That's all we're here to do. Try your best and then make your best a little bit better. Next question in 3, 2, and 1. And that's time, my party people. Go ahead, put those answers in, put a question mark next to your answer. As always, if you're taking a guess, no shame in that. You got it. All right, so let's talk here before we begin. What's our confidence level at? 1 to 10, 1 being lowest confidence we can possibly have, 10 being, yeah, I know I got this one right. I'm good, coach. How are we feeling about this one? All right, so it looks like there's definitely answers all across the spectrum here, and that's okay. Absolutely okay. So this next question is for those of you who are somewhere between the 1 to 9 range. So if it was not a perfect 10, we have to be able to take steps forward. So first question is, Were we able to understand what we are looking for? So again, the question sentence highlighted right here, that is step number one. Do we feel like we understood what was being asked of us? Okay, yeah, you feel like you're getting the first part right, but then once the setup and calculation comes in, that's getting a little confusing. I see. Okay. So let's talk here. They say how many square inches of tape is needed. So everybody, just like we talked about earlier, is this by itself the dead giveaway? Is this by itself how many square inches? Is that by itself the dead giveaway, or do we need more information? Okay, I see a couple of folks saying yes here, but I want to correct you. So it's actually going to be not quite yet. And here's why. Again, this is me just reinforcing that understanding and comprehension because I don't want you to memorize. I really do want you to understand this. So remember, we see square inches here, and I know it's super easy to get excited and think square inches, that's surface area. No, surface area, or excuse me, square inches by itself, that is talking about area. Square inches is area. Now, the question is it area of a two-dimensional shape, a flat shape, or are we doing surface area of a three-dimensional shape? So that's the clue here. The clue is we have square inches, so we know at least it's not volume. It's square inches, so not volume. But now we want to ask, is this regular area of a flat shape or is this surface area of a 3D shape? And everybody, what gives it away that this is actually surface area and not regular area? What gives it away when you read through the first sentence? What gives it away? Yeah, there's actually a couple of things that give it away, right? There are a few things. First, we have the block of foam being 6 inches wide, long, and high. So we have 3 dimensions given to us. We also have another hint here that says all of its faces will be covered in tape. Again, we're not talking about, we can't cover a two-dimensional, we can't cover that in tape. What? All of its faces? There's only one face. So this is not two-dimensional. This is three-dimensional. This is three-dimensional, which tells us that if we're covering all the faces with tape, that indeed is surface area. So yes, square inches, talking about area. And since we're talking about an object that has a width, a length, and a height, then we're talking 3D. So this is surface area because we're covering the front, the right side, the top side, the left side over here, the bottom, and then the back. So my party people, before I continue, again, it's so important that we drive in, in terms of these clues and nuances. So y'all tell me, is that making sense to you? Why we are confident that this is surface area. Sweet. Sweet. Again, I want the best for you guys. I really do. I don't want y'all to memorize. I really do want us to understand this front to back. So with that, now that we know we're dealing with surface area, let me move this off to the side. Now that we know we're dealing with surface area, and that's what we're trying to find, would someone kindly, oh, Virginia, man, stealing my thunder. You guys are, it's almost like you know how I like to teach. I love it. So yes, Virginia, the surface area formula is going to be double the length times the width, plus double the length times the height, plus double the width times the height. Again, just mixing and matching each of those 3 dimensions. With that said, let's go ahead, plug and chug, and let's calculate. So we have our values here, 6 inches wide, so my width is 6, 5 inches long, so my length is 5, and then we have 4 inches high, so my height is 4. Now I'll go ahead and just plug and chug. That's funny. So now we'll go ahead and plug and chug, and we're good. So here we go. Surface area equals double the length. The length is 5. The width is 6 plus 2 times the length is 5. The height is 4 plus 2 times the width is 6. The height is 4. And then you just make sure that you plugged everything into the right place. Length is 5. Width is 6. Height is 4. Each of them should appear twice. There you go. Now it's just time to calculate. Here we go. So we'll have 2 times 5 times 6. So 2 times 5 is 10. 10 times 6, that's 60. Next, we have 2 times 5. That's 10 times 4, that's 40. Oh man, that's pretty easy because already this is 100. That's already 100. So that's going to make whatever this is super convenient to add on. So then we have 2 times 6. That's going to be 12. 12 times 4, that's 48. We add that together and we get 148 as that surface area. And there we go. There we go. 148 square inches is the amount of tape that you'll need to cover this rectangular block of foam. And booyah, there we are. Answer here is D. So who's feeling even better about this one, including our ability to plug and chug? Because I definitely will empathize with that comment there, that plugging and chugging is one of the hardest parts. And I really want to reinforce that it's probably only because we just haven't had enough practice yet. It's hard until it's easy, right? So Michael, great question. So your question was, hey, do we only need division when we're finding the surface area? Incorrect. It's going to be, we need division when we're working backwards. So if we are already given the volume or given the surface area and we're trying to work backwards, because we multiply moving forward to work it out directly, so working backwards at some point, you will have to divide. I gotcha. So for those of us that are saying that the formula is hard to memorize, well then again, hey, that's where flashcards come in. That's where you got to practice over and over and over again, really drilling that in. And then practicing so you understand what the formula means instead of just having some formula memorized. So with that said, who's ready for the next one? Sounds good. Here we go. Let me get the timer up on the screen. Right over here at the bottom right. And here we go in 3, 2, and 1. Let's go. And that is time, everybody. Go ahead. Put those answers in. Put those answers in. What do you have? Put a question mark next to your answer if you might be taking a guess. Again, never any shame in that. All right. So, where's our confidence at with this one? 1 to 10. How do we feel about this one? How did we feel we did here? Yeah, no pun intended. On yeah, because if you're saying 10, then I mean, yeah, the answer is 10. So let's go ahead and give this one a shot here. And I'm glad that a lot of us are feeling a lot better about, again, just taking things slowly. Step 1, read the question sentence. Don't worry about all this. Just the question sentence. How tall is the container? That's what we want to know. So we have some container and we want to know how tall it is. Everybody, what measurement is the same as saying tall or how tall? What measurement is that also indicative of? Yeah, that's right. That's the height. So how tall something is, it's the height. So that's what we're looking for, and we can write that out right here. We're looking for the height. Next up, now that we know what we're looking for, again, I'm not sure how we're going to find it yet. I have no clue. This is all I've read so far, but we have extrapolated the information that we need, what the height is. Cool. Now it's time to start from the very beginning over here. We're going to read through and understand what it is that we're given. A rectangular prism has a base measuring 4 inches by 3 inches and can hold 120 cubic inches of sand. My party people, they tell us immediately that we're dealing with a rectangular prism. So we know that's what it is. So let me just do that right there. We know we're dealing with a rectangular prism. It's probably going to be the other way. So let me just go ahead and turn it this way. So there it is. Now, the next part is they gave us the base, which is 4 inches in length, 3 inches in width. You can go ahead and interchange those, doesn't really matter. So we have these two measurements. We're looking for how tall it is. So we've confirmed that this is a 3-dimensional problem. However, are we dealing with volume, surface area, or something else? Well, that's where the clue is right here. Let me go ahead and highlight this in blue. So it can hold 120 cubic inches of sand. 120 cubic inches, yeah, that's volume all the way. All the way. So we are given the volume as 120 cubic inches. Again, the key here, the key is cubic units, cubic inches. We have the length as 4 inches. We have the width as 3 inches. And so from here, we just have to make the relationship. The relationship is, hey, we're given volume, we're given length, we're given width. How is the height connected? It's all connected through the formula. Volume equals length times width times height. And so now that we have all of that set up, let's plug in what we have and then see what else we have to go. So here, 120 is the volume. The length was 4. The width was 3. The height, we're trying to figure that out. So up next, let's just clean things up. 4 multiplied by 3, that's going to be 12. 12h. And then we have 120. So lastly, all we need to do is divide both sides by 12, and we are set. The 12 is canceled out, and then h equals 120 divided by 12, and that's going to be 10. 12 times 10 is 120. So there we go. There's our height, 10 inches. There we go. And the answer is B. So even if you made a mistake, who here feels like they understood what that mistake was after taking a look here? Yeah. Darian, you instantly saw your mistake? Good. I'm glad. Again, because remember, it's not about being perfect. It's really not. It's really about, hey, if we make a mistake, do we have the humility to learn from the mistake? Can we get better from it? Or are we going to run away from the mistake and then risk making the same mistake over and over and over again? Exactly, Catherine. It's about understanding, not memorizing. And so that's why I always say, leave your ego at the door. We're here to learn. Mistakes are going to happen. And we're here to kind of sort through all that mud so we can come out of this more confident than we were before. Excellent. So with that, let's keep the party going here. We've got a couple of questions left. All right, so let's go ahead and get the next one going. So here we go. And yeah, if it's just a matter of, hey, you plugged in the wrong number, hey, that's a lot better than not having a clue of what to do to begin with. So it looks like a lot of us are really improving here. So here's the timer. Let's keep the party going. 3, 2, 1, let's hit it. And that is time, my party people. Go ahead, put those answers in. Put a question mark next to your answer if you believe you're taking a guess. Alrighty, so where's our confidence with this one? I see quite a few question marks on those answer choices. So how are we feeling about this one? Where's our confidence at? 1 being, again, the lowest of the lows. 10 being, we know we got this right. How are we feeling? Okay, all right, let's give it a go here. So remember, regardless of how we felt, we can always start by reading the question and then going through to the information. So reading the question sentence or the directions here, it says, find its height. So regardless of whether or not you know the formulas and can calculate confidently, you don't need any of that to just read. Find its height. So I'm looking for the height. of whatever it is that we're talking about. Then, from here, we're going to read through the information to understand what it is that we have. So here it says clearly, a rectangular box has a length of 5 inches, a width of 3 inches, and an unknown height. So we're talking about a rectangular box. So let me just copy one of the boxes from over here. Let me just grab this, copy you, bring us over here. All right, there we are. So it has a length of 5, a width of 3, and we don't know what that height is. So that information we're good on. But then up next it says the total outside measure of every rectangular face. So adding up all of these faces, keyword faces, we get a total of 94 square inches. Everybody, what is that indicative of? The two hints that I just gave you were every rectangular face. So the total outside measure of every face, and then you have square inches being given to you. Yeah, all day. All day, that's gonna be surface area. All day. So for those of us that were confused on whether this was volume or surface area, does the green highlighting here, does that help you out? Does that make a little more sense for you personally? Sweet. I'm glad. I am glad because remember, it's not about the numbers. It's about what the numbers mean. So now that we're here, let's write out that formula. Y'all have already done a great job of sharing that in the chat box. We're dealing with the surface area of a rectangular box or a prism, which is going to be double the length times the width, plus double the length times the height, plus double, and let me make this a little smaller. If it feels like following my request, that's great. 1 second. Let me see if that does the trick. There it is. Okay. So then we have double the width and the height. So now what we're going to do is simply plug in the values we have and then see what the rest leads the way to. Everybody, what are we replacing the surface area with? What are we replacing the surface area with? Correct. That's going to be 94. So we see it right here. The total outside measure, that is surface area. So 94 square inches, plug that right in. Next, we understand so far that our length is 5, our width is 3, and again, that height is unknown. So we're going to plug in what we have. Make sure to always write that 2 in front. Then we have 5 for the length, 3 for the width. Then double the length, 5. The height just stays as h because that's what we're looking for. And then we're adding twice of the width. The width is 3. And then, let me write that better. And then the height is just h. So now that we're here, okay, great. Let's just clean things up and then go from there. So we have 94. Then we have 2 times 5 is 10. 10 times 3 is 30. Then from here, we have 2 times 5 times h, and that'll be 10h. From here, we have 2 times 3 times h, and that's going to be 6h. Boom. Now that we're here, let's continue to clean things up. So up next, we have these two terms that can be like terms. We will combine them. 10 plus 6, that's going to give us 16. So we have 94 equals 30 plus 16h. So now that we're here, hey, yeah, we're trying to get h by itself. That's what we're trying to do for sure. And JMO, if this is where you got stuck, I'm glad that you were able to make it this far. I really am. And now at this point, this is where we are solving equations. And this is where I have to remind you that, even if right here at this current moment in time, we're not confident with solving equations, you now know that this is something you need to work on. So, you know where to find the practice inside of the program. You know what you need to do. If you need to go back and continue practicing solving equations, do it. Do it. So let's rearrange it to make the setup a little easier for ourselves. Because remember, 1 plus 2 is the same as 2 plus 1. Let me zoom on in a little bit. Don't worry, I'll zoom on out at the end to let you screenshot it. So we have this, or we can just say 94 equals not 30 plus 16h, but 16h plus 30. They both mean the same thing. Again, 1 plus 2 is the same as 2 plus 1. So to solve this, first step is to get rid of that 30. The way that we'll do that is by subtracting 30 on both sides. Now that we're here, we'll go ahead, cancel out on the right, and then we have 94 minus 30, which is 64. 64 equals 16h. And now that we're here, we are going to get the h by itself by dividing both sides by 16. So from here, divide by 16 on both sides, canceling out on the right side, leaving me with just h by itself. 64 divided by 16. If you want to make it simpler for yourself, you can divide by 4 or you can divide by 8 first, because 8 does go into both 64 and 16. So if you divide them both by 8, let me use a different color here. Let's use red. So I can divide by 8, divide by 8, giving me 8 over 2. And then 8 over 2 is 4. So my height is 4. And there we go. There we are. And our final answer is B, 4. So one more time, Nicholas, I got you. So again, I love these questions because this is telling me that you're intrigued in terms of understanding the why. So how we know that, again, we're dealing with surface area is the first hint is that we see square inches. So that's not volume. Volume would be cubic inches, not square inches. So now we know we're dealing with area, but we want to know if it's regular area or surface area. We know that it's surface area because we're talking about the total outside measure of every face. So the front, the top, the right side, the left side, the bottom, and the back, all of that together, if we add up every face's area, we end up getting 94 square inches. So that's how we know that that's surface area. That's how we know. And then from there, boom, that's what's going to tell us to lay out our formula for surface area for a rectangle, or rectangular box, excuse me. And then from there, we plugged in what we know. The length was 5, the width was 3, and the surface area was 94. Once we plugged everything in, boom, then it was just sorting through the mud, cleaning things up, adding like terms. And then once we had the equation, then it was just a matter of solving it. And so again, if we were confused, like if we understood everything up to this point here, and then this is where we got confused, that's how you know that you need to work on your ability in terms of solving equations. That's all that is. That's what this last part is. After we plug in the values, everything from there on out, that's all about solving equations. And so again, we know it's surface area because square inches, volume would have been cubic, 3-dimensional inches. So with that, Townsend, the answer to that question is yes. You are going to want to memorize it for sure. You want to memorize it. And in order to memorize it, to commit it to memory, it's really going to be about practice. Like, for example, how do you memorize somebody's phone number? Well, dial their phone number a couple of times. Once you dial that phone number a couple of times, it might take 2, might take 5 times, might take 8 times. But once you dial that phone number enough times and you apply it, then you commit that phone number to memory. Same thing with this formula. When you use the formula enough times and you use it enough times correctly, it will be committed to memory for sure. So let's go ahead and try one more problem out. Hey, no problem. Let's go ahead and try one more out. Who's ready to try one more problem out to really test things out? All right, sounds good. Let's get it. So here we go. Let's put the timer right here on the screen. And here we go. 3, 2, and 1. All right, time's up, my party people. Go ahead, put those answers in. Put a question mark next to your answer if it's a guess. Let's go ahead. Let's go ahead and get this last one done. So, yeah, okay, I see some of the confidence here in some of your answer choices. That's pretty good. Let's go. So, here we are. Let's get the timer out of the way and let's wrap up this class the right way. Here we go. So, the question reads, how many cubic inches does it hold? How many cubic inches does it hold? So, there it is. We can clearly see that, this is a trigger word, right? Cubic inches, cubic units. That screams volume. Screams volume. Cubic inches. So, boom, we know for a fact we are talking about volume. And so, is it a matter of calculating the volume, or are we already given hints at the volume that we can work with? Because, not every word problem is going to have you calculate it start to finish. Sometimes they might give you hints. Here, it is going to be start to finish. They give you the measurements of this rectangular box, so you're going to be dealing with our volume formula, length times width times height for a rectangular box. And then we see that the measurements are 4.2 inches by 3.5 inches by 2 inches. Sweet, sounds good. So we're going to write that out and we're done. Our volume is going to be 4.2 times 3.5 times 2.0, or just 2. And so from here, I'm actually just going to write 2. Don't even need to write the 2.0, but that's it. We're going to calculate this together and we're good. Did anybody freak out or pause just because we had decimals? Did anybody pause because we had decimals? Good. I'm glad that the majority of us said no. And remember, if decimals are freaking you out a little bit, remember that decimals, fractions, big numbers, small numbers, negatives, they're all just numbers. And so we have to work with them. We have to know how to work with them. They're just different rules for different types of numbers, but they're just numbers at the end of the day. You never want to, put yourself in a position to not get the points that you deserve just because you didn't know how to do something that you've experienced before. So just as a reminder, you're good. So with that, we know that we are looking for how many cubic inches. So that's what gives away volume. It doesn't matter what order you multiply in because 1 times 2 times 3 is the same as 3 times 2 times 1. So totally fine there. So now that we're here, volume equals, let's multiply. I'm going to keep it simple for myself because 3.5 times 2 is going to give me a whole number. So let me do that first, and then I'll multiply whatever I get by 4.2. So 3.5 multiplied by 2, 5 times 2, that's going to give me 10. Carry the 1. Then we have 3 times 2. That's going to give me 6. Carry the 1 is 7. So there we have 70. But remember, when we're multiplying by decimals, we go ahead and ignore the decimal, and then we bring it back at the end. So here we have, boom, boom, 7.0, or just 7. So next up, we're going to be writing 4.2 multiplied by 7. And so that's where we'll come back and we'll do 4.2 multiplied by 7. So 2 multiplied by 7 is going to give us 14. 4 times 7 is 28. Carry the 1 is 29. And so just like we said previously, we have 1 decimal place moved, so we'll bring 1 back. So our volume here is 29.4 cubic inches. And there we are, my party people, 29.4, giving us the correct answer of B right there. Booyah, my party people. How are we feeling? How are we feeling about this one? Or, how are we feeling about the class overall, first of all? Because, think about, and I have the recordings already, right? Think about how we were when we started class yesterday. How we were going through these formulas, we were going through these keywords, and we were stressed just to plug things in. Look at you guys now. The same group that was here yesterday was scared to all poop. And now today You're looking at this like, oh yeah, that's volume. Oh yeah, that's surface area. Oh yeah, I'm plugging this in. Oh yeah, just do that and divide. Like, look at the progress that y'all have made. And even for those of y'all that joined us today and weren't here yesterday, you still made great progress. So this is what it's all about. I say that all the time. It's about getting one day better, one day at a time. And that's ultimately what's going to spell success for you. So continue moving forward and getting the practice you need, because it's not just about feeling good right now. It's about guaranteeing that we'll feel good on test day.